Welcome my dear students. Today's topic is logarithm. Okay. So in the last class we completed just the exponential function. So y equal to f of x is equal to a power x. It is called as the exponential function. Here the domain is minus infinity comma plus infinity and the range is 0 to infinity. I think all you know the diagram. Okay. So exponential function diagram and logarithmic function diagram. It is just so look at here. So it may be like this, and logarithmic means it is just the inverse of that one. It is inverse of the exponential function. It can be written as x equal to log y base b. Okay. So y equal to a power x is the exponential function. If we rewrite that one as x equal to log y base b, it is called as logarithm. Okay, here base value is b. For example, 2 power 4 we know that it is 16. Okay, so it can be written as log 16 base 2 equal to 4. It is a logarithm. Okay, and it is inverse of 1. It is just a mirror image of about the line y equal to x, or I think so it is the diagram. It is a diagram for logarithm. So obviously look at here, the domain is 0 to infinity and domain is 0 to infinity and the range is minus infinity to plus infinity. So remember that exponential function domain and range, logarithmic function domain and range. Okay, simply I am once again repeating, if y equal to a power x means x equal to log y base b. Okay, I gave one example. Next, properties of logarithmic function. Okay, a power log x base a power log x base a. I think just now I said that both are inverse. Okay, inverse of the exponential is logarithmic, so we can cancel. We are getting only x. Okay, where x belongs to 0 comma infinity. Okay, suppose log a power y base a, log a power y base a is y, because okay, so y belongs to r. Next, second property. Okay, it is called as product property. Okay, quotient product rule, quotient rule, power rule. Okay, and change of. Okay, now look at here, log x into y base a can be written as log x base a plus log y base a. Similarly, quotient means log x base a minus log y base a. Log x power r base a can be written as r into log x base a. It is power rule. Okay, and the change of the thing, log x base b can be written as log x base, 80 minutes student. Log x base b can be written as, log x base a divided by log b base a. Okay, so first remember the general logarithmic form. If y equal to a power x means it can be written as x equal to log y base b, and the properties. Okay, so inverse of the third one, so it can be written as x, and remember the property, product rule, quotient rule, power rule, and change of base. We are changing the base b to a. Okay, change of base rule. Remember the properties, domain, especially the domain and range of the logarithm. My dear students, in the previous one I just did a rough diagram. It is not exactly correct. I am giving the exact diagram for the power exponential function and the logarithmic. Okay, so it is the diagram for the exponential function. So look at here, domain x value from minus into plus infinity. Okay, but y value, the range is nearly approaches to 0 but not exactly. It is asymptotic to the x-axis. Okay, this side. Therefore here I am giving it is y equal to some a power x. So that's why the domain is minus into plus infinity and the range is 0 comma infinity. Similarly, it is the logarithmic function. Okay, so x equal to log y base a. So again it is not exactly 0. Okay, therefore the domain is 0 to infinity. That's why we are putting open interval. So domain is 0 to infinity. Okay, and the range is minus into infinity. Just know the exact diagram and the domain and range. Let b greater than 0 and b not equal to 1. Express y equal to b power x in logarithmic form. Also state the domain and range of the logarithmic function. Okay, so simply to write in the logarithmic form, apply log on both sides with the same base. So log y base b can be written as log b power x base b. Okay, so log y base b equal to, use the power rule. So it can be written from x into log b base b. So remember that the log value and the base value is same, then the logarithm value is 1. Okay, so log y base b equal to x, or x equal to log y base b. It is the logarithmic form. Just now I explained with respect to the diagram. Okay, so the domain 0 comma infinity open, and the range, okay, minus infinity comma infinity. Exercise 2.12, question number 2. Compute log 27 base 9 minus log 9 base 27. So first you can rewrite as log 3 cube base 9 minus log 3 square base 27. Okay, and use the power rule. 3 into log 3 base 9 minus 2 into log 3 base 27. We are using that rule. Okay, log a to the power b equal to b into log a, using that property. Okay, again, so change of base rule. If we move this one to the denominator, there is a change in the base. So log, okay, 9 base 3 minus 2 by log 27 base 3, change of base. Okay, so 3 into log 3 square base 3 minus 2 by log 3 cube base 3. Okay, so 3 by 2 into log 3 base 3 minus 2 by 3 into log 3 base 3. So it becomes 1. So 3 by 2 minus 2 by 3, take the LCM as 6. So 9 minus 4, 5 by 6. So which is the answer? Question number 3. Solve this equation log x base 8 plus log x base 4 plus log x base 2 equal to 11. Solve and find out the value of x. Okay, listen here. So just take the, apply the change of base rule. Just move into the denominator. 1 by log 8 base x plus 1 by log 4 base x plus 1 by log 2 base x equal to 11. Okay, so it can be written as 1 by log 2 cube base x plus 1 by log 2 square base x plus 1 by log 2 base x, no change. Okay, so it can be written, apply the power rule. 3 into log 2 base x plus 1 by 2 into log 2 base x plus 1 by log 2 base x equal to 11. So take 1 by 2 log 2 base x. What is remaining? 1 by 3 plus 1 by 2 plus 1. 1 by 1. Okay. So take the LCM. It is 6. So it can be written as log okay, x base 2. 1 by log 2 base x can be written as log x base 2 into take the LCM. So here what about the 2 plus 3 plus 6 by 6 equal to 11. So 2 plus 3 5, 5 plus 6 11, so 11 cancel. So just cross multiply. Log x base 2 equal to 6. So log x base to 2 is 6 means which implies x equal to 2 power x. So logarithmic to power function. So log x base 2 equal to 6 means x equal to 2 power 6. Okay. So what is 2 power 6? X equal to 64. That is the answer. Question number 4 in the exercise 2.12. Solve log 2 power 8x base 4 equal to 2 power log 8 base 2. So look at here, we have the property, first property, a power log x base a is x. So apply the property for the right hand side, so it becomes 8. Okay. Then apply the power rule for the left hand side, log a power b equal to b log a. Apply that property, we are getting 8x into log 2 base 4. This 8 cancel. So it can be written as x by change of base rule, log, okay, 4 base 2 equal to 1. So x equal to, it can be written as log 2 square base 2, cross multiply. So x equal to 2 into log 2 base 2. It is 1 again. So x equal to 2. This is the answer. Okay. Question number 5 in the exercise 2.12. The question is, if a square plus b square equal to 7ab, then so that log of a plus b by 3 equal to 1 by 2 into log a plus log b. Our aim is to prove log of a plus b by 3 is equal to 1 by 2 into log a plus log b. So that is our aim. Okay, listen here. Here is the hint. So a plus b the whole square, you can imagine. So if we need a plus b the whole square means just apply add 2ab on both sides. So a square plus b square plus 2ab equal to 7ab plus 2ab. So it is of the form a plus b the whole square equal to 9ab. Okay. So taking the positive square root, we are getting a plus b equal to 9. Square root of 9 is 3. 3 into root ab. Okay. So a plus b by 3 equal to, it can be written as ab the whole power 1 by 2. Okay. So now apply log on both sides. Log a plus b by 3 is equal to log ab the whole power 1 by 2. Log a plus b by 3 equal to 1 by 2 into log ab. So apply the product rule. Log a plus b by 3 is equal to 1 by 2 into, don't forget to put the bracket, log ab can written as log a plus log b. So hence we proved. But since in the exercise 2.12, prove that log a square by bc plus log b square by ca plus log c square by ab equal to 0. So let me take the LHS. So we know the logarithm product rule. Log ab equal to log a plus log b, vice versa, log a plus log b equal to log ab. Similarly, log a plus log b plus log c means log abc. So use that property here. Directly we are getting the answer. So log a square by bc into b square by ca into c square by ab. Product a b c means, or if we consider x y z means log x plus log y plus log z means log x into y into z. So log of, what is the numerator, a square b square c square by So a into a square, b into b square, c into c square. So cancel log 1. So log 1 value is 0.